So let's talk about one of the biggest and maybe most intimidating jumps in data science. How do you take a brilliant machine learning model that's stuck on your laptop and actually get it out onto the web where anyone can use it? That's the journey we're going on today. Okay, so picture this. You've spent weeks, maybe even months, building this incredible AI model. It works perfectly on your computer, it's making amazing predictions. But now what? How does it break out of that cage? How do you turn a file on your hard drive into a living, breathing tool that people can actually interact with? That's the big question we're here to answer. All right, so the very first thing we have to do is kind of shift our mindset. We need to stop thinking of our model as just a tool for a one-time analysis. The real magic happens when you transform it into a live service, a predictive engine that's always on, ready to make smart decisions in real time. And look, this isn't some far-off futuristic concept. You're using this stuff every single day. When your email inbox magically knows what's junk, when Google gives you that perfect search result, or when Netflix somehow knows you're in the mood for a cheesy 80s sci-fi flick, you're using a deployed machine learning model. But before we can even dream of going live, we often smack right into a giant wall. A wall made of data. You see, a lot of the time, our data sets are just way, way too big to fit into a normal computer's memory. So what are you supposed to do then? Well, the old school way is what we call in-memory. It's like trying to drink an entire lake in one gulp. It's just not going to happen. Your computer's going to choke and the whole thing will crash. The much smarter approach is called out-of-core processing. Instead of trying to swallow the whole lake, we just teach our model one small, manageable sip at a time. And that's the official term for it, out-of-core learning. It's all about learning outside of your computer's main memory. You feed the model little bits of data, it learns from them, you feed it some more, and so on. This is the absolute secret sauce for tackling massive data sets without needing a supercomputer. Okay, that sounds great in theory, right? Feed it data and little chunks. But how do we actually do that? Well, you can't use just any old algorithm. You need a special kind of tool for the job, one that's designed to learn piece by piece. And the hero of our story, the engine that makes this whole thing possible, is an algorithm called stochastic gradient descent, or SGD. Now, most algorithms are like students who have to read the entire textbook before they can answer a single question. SGD is different. It's a fast learner. It can learn a little something from every single sentence it reads, one at a time. This makes it ridiculously efficient and perfect for what we're trying to do. So here's how it works in a nutshell. First, SGD makes a totally random guess. It's probably way off. Then it looks at just one piece of data and asks, okay, how wrong was I? It calculates that error and then nudges its own guess in the right direction, just a tiny nudge. And then it does it again and again and again, thousands of times, getting a little bit smarter with every single step. Okay, so we've solved one problem, but wouldn't you know it, that creates a new one. This is especially true when you're working with text. You see, a standard tool like Count Vectorizer needs to see all the text up front to build a big dictionary of every word. But we can't load all the text up front. It's a classic catch-22. But don't worry, there's a super clever solution, and it's called the hashing vectorizer. This thing is awesome. It doesn't need to see all the words in advance. It uses a little bit of mathematical magic, a hashing trick, to instantly turn any word into a number, on the fly without building a dictionary. It's perfect for our one sip at a time approach. Now, let's be real for a second. There is a trade-off here. By doing things this way, you might lose a tiny, tiny fraction of a percentage point in accuracy. But what you get in return is, well, everything. You get incredible speed. You get feasibility. It's the difference between having a model that actually finishes training and one that just sits there and crashes your computer. All right, we did it. Our model is trained, which might have taken a good while. The last thing we want to do is have to repeat that process every single time we start our app. It's like playing a video game without a save button. We need a save game feature for our model. I mean, seriously, can you imagine that? Every time a user opens your app, they have to wait for hours while it relearns everything from scratch? No way. That's not just inefficient, it's completely unusable. And the solution here is wonderfully simple. In Python, there's a library called pickle. What it does is basically take a snapshot of your fully trained model. It freeze-dries all that hard-earned knowledge and packs it into a single file. Then, when your app starts up, you just unpickle it, and boom, it's ready to go in an instant. Okay, so let's take stock. We have a smart model that can handle huge amounts of data, and we can save and load it instantly. What's missing? Well, a way for actual humans to use it. We need to build a front door for our model, and that's going to be a web application. And one of the best tools for that job is a Python framework called Flask. Flask is just fantastic because it's super lightweight, there's no fuss, and it lets you spin up a simple web server really, really fast. It's the perfect bridge to connect a user's web browser to your powerful model in the background. We're so close. This is the home stretch. We have our model, we have our web app running on our computer. Now it's time for the final, most exciting step, pushing it out to the cloud so it's live on the internet for everyone to see. To make that happen, we can use something called a platform as a service, and a really popular one is Heroku. The best way to think about Heroku is as a service where you just give it your code, and it takes care of all the messy, complicated server stuff for you. You don't have to worry about setup or maintenance, you just focus on your app. And getting your code ready for Heroku is surprisingly simple. You just need to create a few little text files. There's one called requirements.txt. That's just your project's shopping list of all the Python libraries it needs. Then runtime.txt, which just tells Heroku what version of Python to use. And the last one, the proc file, is like the ignition key. It's the exact command Heroku needs to start your web server. And honestly, that's pretty much it. Once you have those files in your project folder, you just push your code up to Heroku. It's the same simple git command you'd use for GitHub. Heroku sees your code, reads those little instruction files, and automatically does all the heavy lifting to launch your application. And just like that, you've done it. Take a second to appreciate this moment. You've gone the whole distance, from a Python script on your laptop to a fully functional live machine learning service on the internet. That's a huge accomplishment. This is where things get really fun. Your model isn't a static project anymore. It can provide real value to users. It can process new data as it comes in, and you can even set it up to keep learning from that new data, getting smarter and smarter all the time. So there you have it. You've unlocked the true potential of your work by taking it from theory to reality. You now have this incredibly powerful new skill. So the only real question left is, what are you going to build with it? What problem are you going to solve next?